Hello everyone, this is Swagatam. So today I'm going to start perform the another kinetics derivation that is related to our enzyme kinetics, which is Adey-Hofstee equation. This equation is also pretty much important for your exam point of view. Now, to perform this Adey-Hofstee equations, I would like to say one thing, that if you don't have any idea regarding the Michaelis-Menten equations, then this equation will be quite tough to understand for people. So at the very first steps, I would like to suggest you that please check it out, the concepts of Michaelis-Menten equations. I already made two video lecture regarding the Michaelis-Menten equations. You can search it out on my playlist. And though there is not present any graphical representation of Michaelis-Menten equations, but very soon I will also going to upload the graphical representations of Michaelis-Menten equation. Okay, so those who already know the Michaelis-Menten equations or how to derive the Michaelis-Menten equations, then this video will for them. So in case of Michaelis-Menten equation, we have seen that V0 is equals to Vmax dot concentration of S divided by Km plus concentration of S. Here V0 is equals to the initial velocity, Vmax is equals to the maximum velocity, and concentration of S is actually denoting the substrate concentrations. And all of us we know that Km, that is the Michaelis-Menten constant. So we just have to rearrange this equation, that is Vmax dot concentration of S is equals to V0 dot Km plus V0 dot concentration of S. Now let's write it in this way: Vmax is equals to V0 Km divided by concentration of S plus V0 concentration of S is divided by also concentration of S. Now V0 is divided by Km concentration of S plus V0. Okay. Now we can write it in this way: V0 is equals to Vmax minus V0 dot Km divided by concentration of S. Or also we can write it in this way, that is the minus Km V0 is divided by concentration of S plus Vmax. Okay, just a minute. So this is whatever the equations, that is V0 equals to minus Km, V0 is divided by concentration of S plus Vmax. So this is the Adey-Hofstee equations of enzyme kinetics. Now if you consider the V0 as a y-axis, and Km is minus m, and V0 y as the Km is here acting as a slope, and V0 y is acting as a x-axis input, and here Vmax is acting as an intersect of y-axis. So this is the graphical equations. Now if we draw a graphical representation, then it will be like here you can see that the value of m, that is the slope is here, the minus Km, and the x-axis value is here V0 by S. Now if you consider this is an x-axis, this is the y-axis, then the value should be like V0 divided by concentration of S. Now here the value of y is also the V0, so this is the V0, and now you can see over here that the x-axis intercept. If you draw a graphical representation like this way, then this point is actually showing the x-axis intercept. Now how you find out the x-axis intercept? Now to find out the x-axis intercept, is formula is minus m by c. So as the value of m is here is also negative, so it will be only m by c. Got it? So here the value of m is minus Km, so as it is positive, so it will be only Km, and the value of c is over here is the Vmax. So this is the x-axis intercept, and the value of x-axis intercept will be Km by Vmax. This is the value of x-axis intercepts. On the other hand, if you see the y-axis intercepts, then this is actually the value of c, and c is only the Vmax. So Vmax. Okay, and the slope. Slope is here, the minus km. This is the slope. Slope is here, minus km. Now remember one thing, that whenever the value of x-axis intercept will be positive, here the value of x-axis intercept is positive, then always the slope will be more than 90 degree. And when the value of x-axis intercept will be negative, that is, if the value of x-axis intercept will be in minus form, then the slope of this graph will be less than 90 degree. Okay, so such type of graph we can see in case of the competitive, uncompetitive, and non-competitive inhibitions, as well as the Lineweaver-Burke plot of Michaelis-Menten equation. We can also see such type of graphical representation. But in case of Eadie-Hofstee equation, as the value of x-axis intercepts is positive, that's why here the slope will be more than 90 degree. So this is the basic difference between the Lineweaver-Burke plots of Michaelis-Menten equation as well as the Eadie-Hofstee equations. So I think this much is sufficient to understand the Eadie-Hofstee equations. In my upcoming video lecture, I will talk about the graphical representations, that is the Lineweaver-Burke plots related to our competitive, uncompetitive, and non-competitive inhibitions, as well as I will also talk about the graphical representations of Michaelis-Menten equation. So thank you everyone for watching my video.